Now let's see electrolysis of copper 2 sulfate using graphite electrodes. So these are inert electrodes. So copper 2 sulfate dilute, so you have Ca2 plus, SO4 2 minus, and water. At the cathode, you can have reduction of Cu2 plus or reduction of H2O. Half equations. So for Cu2 plus, we have this equation, and for reduction of water, we have this equation. So the one that is the more positive is going to be actually reduced. So this is the one that is reduced. Now at the anode, we're going to have SO4 2 minus and H2O. Like we have already discussed in the previous video, SO4 2 minus is never going to get oxidized. It will never going to get discharged. It's already in its highest oxidation state. So we'll have the oxidation of H2O, and oxidation of H2O is this equation. So we'll have to flip it like so. Once we have the two equations, so at the anode and the cathode, we can determine the overall equation. So these are the two equations, so we can combine them, write the overall equation. So two electrons cancel out. So you have the overall electrode potential to be minus 0.89. Now the observations at the cathode. So at the cathode, you have the formation of copper solid. So you'll have a reddish brown deposit at the cathode. And at the anode, you have the formation of oxygen gas. So you'll see effervescence. And for the electrolyte, because you have Cu2 plus that are being used up, so we are depleting the electrolyte from the Cu2 plus, therefore we'll have the color of the electrolyte that will fade from blue to eventually reach colorless. Now let's see what happens when we use copper electrodes instead of graphite electrodes. Now copper electrodes, they are reactive electrodes, which means that they are going to participate in the electrolysis process. So because it's a reactive electrode, so at the cathode you have the electrode taking part in the reduction, so you'll have the reduction of Cu2 plus. So at the anode, you're going to have the copper electrode taking part in the oxidation. So you'll have oxidation. So here, as the overall reaction, you have Cu2 plus aqueous reacting with Cu solid, forming Cu solid plus Cu2 plus. So this is what is happening. So at the cathode, you have the deposit of Cu2 plus, and at the anode, you have Cu2 plus of the electrode getting used up, forming Cu2 plus into the electrolyte again. So Cu2 plus is being used up, Cu2 plus is being produced. So which means that the concentration of Cu2 plus in the electrolyte stays the same, and that at the cathode, you have solid copper being produced, but at the anode you have solid copper being used up. So the observations will be a reddish brown deposit of copper at the cathode, and we'll have a decrease in the size of the anode because Cu is being used up at the anode, and we'll have impurities that we'll see because whatever is not copper of the anode, so the anode is made up of copper metal. So the metal has impurities. So all the impurities is going to be deposited at the bottom of the anode. We'll see the impurities deposited. And the pure copper is going to get converted to Cu2 plus. The electrolyte will not be any different because the concentration of Cu2 plus stays the same. And this type of electrolysis is very useful for purification of metal and for electroplating. Electroplating means that we're coating a metal with a layer of another metal. So you can do electroplating of copper, you can do electroplating of zinc, which is actually called galvanization. You can do electroplating of silver as well. So here you have the setup for electrolysis of aqueous copper sulfate using copper electrodes. And here it's very important that so here you'll see that the impure copper, any impurities from the anode is going to be deposited as a sludge of impurities, and then you have the reddish brown or the pink brown deposit of pure copper. Now it's in some situation we need to have pure copper, for example when you're using copper for wiring. So we use this method to remove impurities from copper. So we'll have the impure copper, which is set as the anode, and then we'll have pure copper, which is deposited on the cathode. So we'll have the object that we want the pure copper to deposit on, and this is going to be pure copper. So we'll have all the pure metal at the cathode, and we'll have the impure metal at the anode. So this is how we do purification of metals. Electroplating is a process where we're going to coat a layer of a metal on another metallic object. So for example, if you want to do silver plating on a spoon, so we'll coat the spoon with a layer of silver. So how do we do that? We're going to have the spoon or any object you want to metal plate as the cathode. So the object is going to be the cathode, and then the metal that you want to coat it with, the metal is going to be the anode. So the metal is going to leave, so the anode is going to get used up, and it's going to form ions, and then the ions are going to get reduced, and we'll have the formation of the pure metal at the cathode. So in order to do electroplating, we'll have the metal as the anode, we'll have the object as the cathode, and as the electrolyte, you will need an aqueous solution of the metal. So it should be something that's soluble in water and that contains the metal ions. So for example, this one is silver nitrate that contains Ag plus ions. So here at the cathode, you'll have Ag plus reacting with the electron giving Ag solid. It is this solid that is going to be coated on the object. And at the anode, you're going to have the solid silver that is going to form Ag plus ions. So you have the oxidation reaction at the anode. Now, in case you're not using a metal, the pure metal, or at the anode, you're going to be using up the silver ions from the aqueous solution. So then each time you will have to replenish the electrolyte because the ions in the electrolyte will be used up.